Now, moving on from how growers can reduce their carbon footprint, some suggestions how they might reduce their carbon footprint with Keris, we're going to focus on how our changing climate will affect UK agriculture, including the opportunities and risks, with Steven Penfield, Professor of Crop Genetics at John Innes Centre in Norwich. His team at JIC is using crop species from the brassica family to understand how weather and climate affect plant reproductive development and seed quality, in particular, the effects of temperature on crop yields, seed quality, and seedling establishment, with the aim of considering strategies for increasing crop resilience, for instance, using conventional plant breeding or genome editing techniques. Stephen, I hope you're with us.
I am, and thank you very much for the introduction, Stephen, and welcome to South Norfolk, where it's a glorious day. I'll just start to share my screen, if that works. I hope you can see that.
That's looking good, Stephen, yeah.
Great. So what I'm going to do today is just summarize quickly what we know, or what we believe is likely to be the future climate situation in the UK, and how this is going to be affecting UK farmers, producers, and the supply chain. And then I'll move on to talking about what we will need to do about it. And there will be some key messages, really, and I think Stephen Howe touched on at least one of them on his introduction, which is that really is the variation in the weather which is going to be the key problem for the UK farming supply chain, rather than warming per se, which actually can easily be adapted to, and farmers are very adaptive. But secondly, that we might need to start demanding some different things from the varieties that we grow, some different things of breeders to increase resilience, rather than focusing on sort of raw traits like yield that we have done in the past. So, as you can see in this little GIF produced by the Met Office, it's important to remember that there already has been a significant level of warming in the UK over the last 50 years. And we're really approaching a kind of 1 degree average scenario. And I think it's fair to say that most farmers, at least, have noticed a change in the weather, but it also is becoming a big enough change that society at large, who perhaps is not as connected to the weather and the natural environment as an agricultural community, they're starting to notice the change too. So this is a study that appeared from the Centre for Ecology and Hydrology a couple of years ago, and it just summarised what we can expect to see, the different types of climate and weather phenomena that occur in the UK, and how these might affect production. So and you can browse the slide for yourself, but you can see that in terms of temperature, that all regions are expected to warm some more, especially in the summer and also in the winter, and I'll come to that in some more detail a bit. And the climate models indicate that there will be important changes in rainfall patterns for which we will have to adapt. And in particular, they predict higher winter rainfall for the UK and lower levels of summer rainfall, which will have wide-ranging impacts to what we do on farms, wherever you live. There are other things where the impacts are less certain, such as sea level rise, which might be locally very important and which could be mitigated by existing technology. But of course, there may be some political constraints as to whether those mitigating options can be implemented. We know that we will see increases in extreme events, particularly flooding, and a decline in snow and frost. So already, I think we had one autumn here where the first frost was on the 2nd of December, which is very, very late, and we will see more of that, less frosts, not just in autumn, but also in winter. But the key thing is they will still occur. So it's not like we're going to get rid of the weather we've had in the past. We're almost embracing a kind of just a broader range of what's possible. Now, this much we know, and I'm guessing that most of you are familiar with those predictions. Exactly how this will look is still, I think, quite hard to envisage. And the last set of UK climate change predictions produced some graphics to try and to introduce people to what the future climate might look like towards the end of the 21st century. And here you can see just two examples they had from winter. On the left, the winter mean temperature for the last 20 years of this decade. And on the right, the average winter precipitation. And what the graphics show is the deviation from the average over the last 50 years. So what you can see is that the top emission scenario is essentially the most pessimistic, the RCP 8.5. This is a carry on as usual emitting carbon, which we very much hope we're not going to do. And the bottom, the RCP 2.8, that's we stop emitting almost immediately. So the most optimistic emission scenario. And then you can see how much warming is possible. And in the middle of each column, you can see that the warming likely in half the years. On the right, the warming likely in the warmest 10% of the years. And on the left, the warming likely in the coolest 10% of the years. And what's immediately obvious is that under some emission scenarios, which are certainly not out of the question, we could be looking at winter warming between 4 and 7 degrees above the late 20th century average in the UK, and increases in precipitation up to 50% in some areas. And that'll make us a very large difference to our perception of what the weather's like and the way in which our crops and livestock perceive the weather too. And just to sort of illustrate that, if we get a sort of 3 to 4 degree winter warming, well, this puts us London somewhere down on the west coast of France, because that's the sort of winter they would experience now, right there. And if we get these really extreme scenarios, this is like transporting London and rebuilding it somewhere in Portugal. And we will have very balmy winters where we will be going around in a t-shirt from time to time, even maybe in December and February. And in fact, we did have temperatures in the 20s in February just last year. So we are starting to experience some of this. This little graphic that the Met Office produced illustrates the daily temperature anomaly in the UK in December 2015. And what you can see is for nearly the whole month, the United Kingdom was between 4 and 8 degrees warmer than average. And this, we start to believe, it had quite important impacts on plants, crops that were growing in the field, and the way they performed. So these are not just theoretical possibilities. These are extremes which are starting to happen. We're starting to experience it, and they're expected to become more frequent. So what are the threats and opportunities? And it's such a wide range. It depends on exactly where you are and what you would like to achieve in your farming business. And I'll highlight some from this slide, but again, you can browse it for yourself. But I think perhaps the most important to highlight is that longer growing season will produce some substantial opportunities, particularly in horticulture, perhaps in covered soft fruit for seasonal extension, and perhaps enable us to produce more fresh produce for longer, increase our food security and reduce imports in winter. And I'm sure we'll hear a bit more about that later. Also for crops like sugar beet, where yield depends on the longer growing season, there may be some opportunities there. So longer growing season, I think, is a clear thing that we could benefit from. We can see that there are opportunities for planting new crops, and we've seen a large spread of people investing in vineyards, particularly in the southeast of England. I'm going to speak a little bit more about that in a minute, but there's obviously opportunities for new crops. But also in the south of England, there's going to be a reduction in rainfall and hot summers. This is going to lead perhaps to cuts and restrictions in your borehole licenses if you irrigate for potatoes, and perhaps a reduction in wheat straw length and lower wheat yields if the growing early summer is very warm and dry. And we have already seen a few seasons like that. If we get more rain in late autumn, we will have problem drilling winter wheat, although the UK climate is predicted to remain favourable for wheat cultivation throughout the whole of this century, even under the most pessimistic scenarios. Some other things I'd like to highlight. I think the effects on the grass growing season, there has been some recent studies on this, and I think that could be very important. So we get a longer grass growing season, which is great if you have livestock out in autumn and spring. Maybe they might go out earlier or stay out longer. But in the south and east, the heat and drought we might experience in the summer might lead to a failure of the grass crop in the summer. And I certainly had this issue in 2018 where I ran out of grass for my sheep, and I'm sure that some of you have experienced the same thing. And I think this could become so frequent to become the norm that grazing in the southeast, we might lose grass in midsummer due to heat and drought. And we'll need to mitigate against that. So it's a mixed picture of threats and opportunities that result just from warming and the change in the climate. As I already alluded to, I don't expect this to be the key problem that we face, because to general change in the climate, we can adapt very clearly. A bigger issue may be that extremes are becoming more frequent. And this is a study by Munich Re, an insurance company, looking at the causes of loss events in the insurance industry. And you can compare the losses through, for instance, earthquake and tsunami, which are broadly stable across the period. And then you can look at the increase in losses due to meteorological events, storms, extratropical storms, floods, landslides, and you see this large increase in events there, which cause losses for insurance companies. And of course, insurance companies are really those with their finger on the button of where the threats are going to arise. And UK farmers have started to notice this. So this study survey from the NFU, which is a little old now, maybe 5 years ago, doesn't surprise me. So 2/3 of farmers say they've seen an increase in extreme weather, and the same number changes in rainfall and flooding. 10% of farmers say winters are getting milder, but I suspect maybe more now would say the same thing. But nearly 60% of farms have been affected by severe weather, flooding or very wet conditions. And we get structural damage. And around 1 in 7 farmers have changed either the types of crop they plant or the way they manage livestock on the farm, which is quite a large number already. So we know crop yields are becoming increasingly unpredictable. And the question is, what do we do about that? And this is where I'm going to start to talk about some changes that we might demand from breeders, from the supply chain, and spreading risk that I think will be necessary to get through agriculture this century. And of course, it's nice for me to see that farmers think we should need more research and government backing to make changes on the farm that will increase resilience. And I think both of those will be essential, because there's still a lot of unknowns. It's very easy to say, this is what we believe is going to happen, but there's a lot of uncertainty still. So for instance, let's say you decide it's going to warm and I'm going to invest a lot of money in a vineyard, which is a substantial investment in infrastructure, planting and the maintenance and so on before you see much return. But wine yields in the UK have a strong relationship to summer temperatures. And if we get a cold summer like we did in 2012, where the temperature was around 2 to 3 degrees warmer than average, actually we see big changes in the wine yield. And I've got this summarized on my next slide from this study from a colleague of mine, Steve Dorling at the University of East Anglia. So this chart shows the average wine yield in hectolitres per hectare, so that's 100 litres per hectare, and the grey bars are the different growing seasons, and the black line indicates the average growing season temperature. And I think you can see on if you look for 2012, the yield plummets right down to 5 hectolitres per hectare, which is less than a seventh of what you can expect in a good year. So if you're planting vineyards, this is the kind of variation that you need to factor into your business plan. It's quite a sobering thought. So really, it's this variation between different growing seasons which is going to create the challenge, even as we adapt to do things differently in a warmer climate. So this brings me to some of our work. We've been looking at oilseed rape, which is another crop where we see large variations in yield between growing seasons. And the yield can fluctuate between about 3 and 4 tonnes per hectare on average in the UK. And obviously, like, different farms will have higher or lower yields, but this is the average yield across all UK farms. And this average of sort of 1 tonne per hectare difference of course, is worth about £300 to £340 to the farmer. But as a country, given the acreage, which we are still growing some despite the flea beetle, but it's dropped a bit, it's worth up to 200 million a year. So in these bad growing seasons, really the country loses a lot of income from the economy. So the question is, what can we do about this? What should we do about this? And that's kind of where I think our role as scientists come in. We've been looking at this in a lot of detail, and the chart on the left just shows the temperature in different months between the highest yielding years, which is in the black line, and the lowest yielding years, which is in the grey line. And I hope you can see that the key difference between the 2 years is that in October, in the low yielding years, the temperature is cooler. And in December, the temperature is warmer. And in the high yielding years, you've got a cold December and a warm October. And if you look at the chart on the right there, if the blue line is above 0, this means that warm temperatures are positively associated with yield. And if the blue line is below the black line, it means that cold temperatures are positively associated with high yields. And you can see that there's an inflection point round about the end of October where warmth goes from being strongly positive for yield, where it becomes bad, and only in the cold Decembers do we get high yields. Now this is interesting because this is exactly when the crop in the field makes the transition from making leaves to flowers. And you can see that on the little chart on the left. Here you can see a growing tip of an oilseed rape plant on different dates. And it starts to make these little ball-like structures in the beginning of November, which develop into the flowers. So as soon as the plant moves, and these are microscopic, you only see if you look closely, it looks like they're still making leaves at the time. If you look closer, they start making flowers. So while the plants are making leaves, warmth is good, but as soon as they start making flowers, then they need cold to deliver high yields. And it's this process that we think is important in this interannual variation in rapeseed yields. And we've been investigating this in several ways. For instance, we've been heating field trials at our field station just outside Norwich in the UK. And this enables us to determine what happens if we have warm weather at different types of year. So these are kind of new techniques we're introducing to the farm to understand the effect of varying weather. And the trial might look a bit like this. So you can see a field trial with different plots and a thermal imaging camera. You can see the nice warm heated plot there compared to the cold plots around it. And we think this type of experimentation is going to start to deliver the types of information we need to learn how to adapt to these more variable conditions. And just in case you are an oilseed rape grower, this trial looks very bad in the next spring, and eventually you've got a lot of flea beetle damage, and I'm sure we're not the only ones to have suffered such things. So we surprisingly find that warming the rapeseed crop in October delays the flowering in spring. So if you look, there's 5 plots here control plots which are unwarmed, and 5 heated plots. And then you can see the different dates where the drone flew over and took an aerial shot in the spring. And you can see the plots flower, and the peak flowering in the control plots on the 25th of April. And then you can see the peak flowering is delayed in the heated plots. So we're just coming into October now. So you can think that the warmer it is in October, that actually the later your crop will flower in the spring. But in our trial, this warming doesn't affect the yields. And so we were interested to why this is, because the cold Octobers, really their average temperature historically has been about 7.5 to 8 degrees, whereas the warm ones, which lead to the high yields, are around about 11 degrees. And if we look in the temperature history of the UK, so this is the longest temperature record in the world, the Hadley Central England Temperature Series. You can see we've nearly eliminated these cold Octobers now it's warmed. And this is the seasonal extension coming to the rescue of farmers already. So these cold Octobers, they used to prematurely transition the crop to flowering, and now they've been eliminated, which is a positive thing. But it's not all good news. So we're using another piece of technology to look at weather variation. And that's these controlled environment rooms, which allow us to reconstruct growing seasons at 15-minute temperature resolutions for entire year. And we can grow crops in these, and then we can transfer some of them to warmer controlled environment rooms at specific time of year. So we can simulate what happens if we have a warm spell. We do this over and over. It's really useful because it allows us to vary the temperature without varying rainfall, solar radiation. There's no pests or pathogens. There's no change in the agronomy. And we can see that doing this has big effects on the crop. It also delays the flowering, results in a small inflorescence, which is a bit disorganized. It produces less seeds and these plants really suffer in the yield from having this warm winter. And this is what we think happened in 2015. We had this exceptionally warm December, and the yield in oilseed rape in 2016 was very, very low across the whole country. And we believe this is what the process is. So using this new knowledge, we can start to discover how this process works, and we can start to understand how to breed the crop to be more resilient. And one thing we've done is gone back and look at all the trials run by the Levy Board over the last 20 years and pick out varieties which have yield which does not vary with the winter temperature. So in these charts, you can see the yield of the different varieties in the trials, and here's just 4 examples, and the temperature in winter. And you can see that as it gets warmer, for 3 of the varieties, the yield is going down. But for this one variety, Castile, we see it's much more stable. And in fact, we've been growing this in the CRs, and we can see it's more stable, and we can breed from this to try and increase the resilience of the crop. So that's what's happening now at the John Innes Centre. We're breeding for this. And we hope that we can make varieties which in the future will allow us to continue growing the crops and achieve high yields even in warm winters. And this is the approach we need to take. We need to demand resilience from, and we need to spread risk on the supply chain, not just let the farmers take the risk, but demand buyback clauses in seed sale contracts and things like that if you don't get the result you hope for from a crop. So the weather will warm, we think, to conclude, but with a range of advantages and disadvantages depending where you are and what your farming business looks like. However, the main threat, we think, is through increasing variation, which will make adaptation more challenging. And the important thing is that cooler periods will still occur. So simply moving practices to warmer regions, although this will work in the majority of the years, you'll still see these cool years where these technologies will fail us. I also told you about how winter warming is also a threat to arable yields, particularly oilseed rape, but we can do something about it through breeding. Now, if you are, just before I finish this, if you're wondering, well, what can I do about this now? Is that you can now begin to ask your agronomist to address these types of problems when they're recommending varieties to grow on a farm. And here's just a quick analysis of last year's recommended list trial data for oilseed rape. And on the bottom, I can show you the yield, and on the vertical axis, the variability in yield between all the different trials that were run up and down the country. And you can see these different colored quadrants. So this is the worst quadrant. The red quadrant is the worst quadrant to be in. Here there's a low yield, but high variability. And this is where you don't want to be, and you don't want to be planting these varieties. Now, you might be brave if you think you're really highly skilled, you've got great conditions for oilseed rape. You could go for a variety in the blue quadrant with a high yield. It might be highly variable, but you think that you can deal with that, and that's great. But there's this sort of magic quadrant, the green quadrant on the bottom right, where you can get high yields but low yield variability, and these are the varieties which are going to deliver the resilience that we want to see. And I think any reputable agronomist will reproduce this type of analysis for you, and will give you some confidence if you want to grow more resilient varieties. And it's really important to start demanding this type of analysis if we want to increase the resilience rather than just go all out for yield. So I'm going to end my presentation there, and I hope you found something new and something of interest, and I hope you also learned something about our research at the John Innes Centre. And I'll hand back to Stephen at the Farmers Club.
Very many thanks for that, Stephen. An encouraging insight into the opportunities for UK cropping. I prefer to look at the opportunities rather than the other side of the story. And more importantly, how research could support UK farmers with climate change. The biggest challenge of which, of course, as you said right at the beginning there, is the weather volatility, which is something, of course, that I think the government appreciates as well, and hopefully they will look at that and make sure they invest in our research and development, which is second to none in the UK at the moment, particularly when it comes, of course, to plant breeding. Now, I have a number of questions here. As you gather, we're trying to juggle the questions and listen to you at the same time. It's very difficult. I can't do that, being male. But anyway, the first question I've got here is from Alan Horgan. Can we predict certain cropping being unable to be grown in midsummer, e.g. lettuce under heat stress despite 2 irrigations a day? I guess Alan grows lettuces.
I guess the short answer is that I would defer to an expert in the growth and cultivation of lettuce if they were available. But one of the world's biggest lettuce growing areas is in Southern California, where the weather is much warmer than the UK in summer. So my best guess is that we will still be able to grow lettuce. I've seen cheese growers actually putting out plugs of lettuce in 40-degree heat, and they scatter them on the field, and miraculously they're still there a week later growing away. So it's a surprisingly resilient crop, and I would anticipate that we will continue to grow it even in warm summers.
Oh, that's encouraging to hear. Actually, I've actually seen them growing in southern Florida as well. Similar sort of conditions to those you described, and they seem to grow very, very quickly indeed, but they do have a huge quantity of water down there, as we know. The next question comes from Helen Bates. I hope I understand this one. Sorry, it's a bit tricky. If rising sea levels are included in your predictions, a lot of fertile land will be under water. Also, people will be migrating from coast to inland, putting more pressure on I guess, the quality land that we have available for growing crops. So, and the second part of this question is, have those changes been included in our mitigation strategies?
Right. So again, like my apology, I'm not an expert in the government mitigation strategies for dealing with sea level rise. But what I would note is a lot of these areas are drained already. They already rely on active drainage and pumping, and have done for many years. And if you think about somewhere like the Netherlands, where a lot of the growing land is 4 to 7 meters below sea level, still much of our high quality land will be higher in elevation than the Netherlands. So it will be possible to keep it drained by use of technology. And this is why I said I think probably the biggest limitation is therefore political, whether there is the will and the organisation to implement improvements to infrastructure that will be needed to keep the land in serviceable condition. And I think that's the best answer I can give right now.
Great. And moving on now to another question, this time from James Clark, who's I know is with ADAS. Has Stephen, that's you, not me, factored in the interaction with pests and diseases, both of which could be favoured by warmer winters, and improved resilience to these may be just as important, especially if we don't have the plant protection products available?
Yes, and an excellent comment and very important question. And of course, we would like to do that. And I completely agree with you if you think that this is a big unknown, because we really don't have a strong idea about how that we've seen emerging threats like new pest disease, obviously, and oilseed rape. We're dealing with the flea beetle right now. But we also don't know much about how changing climates will impact the distributions of pests and pathogens, the virulence of pathogens, and the emergence of new strains. So it's really complicated and expensive research, because you need facilities, large facilities, to deal with pests, to deal with crops. And for this reason, I think that the exceptional challenging nature of the research means that not that much has been done of use. And I don't see that changing in the near future. It's unfortunately the case. I think the best we can do is look to warmer regions and see what threats are there and emerging, and anticipate that they're likely to arrive in the UK.
Right, thanks, Stephen. One final question for you here. It's a good simple one. Can't we just use varieties from France and Portugal? Or even, I'll add one in there, from the southern USA. And that comes from Alan Morgan.
Yes, well, I think that's absolutely right. We certainly can use, perhaps not varieties, because varieties tend to be very specifically adapted to different growing regions. But I think in general, you are correct in that we can use gene variants in breeding and varieties in breeding from these regions, and combine them with varieties which we know work here and produce more resilient crops. And I think that's exactly the type of thing that breeders will be looking to do.
Thanks very much for that. And thanks very much indeed, Stephen, for your presentation and for answering those questions so well.